Easy BTech. Myself, Ravi Kumar. In this video, I am discussing about the voltage and current equations in circuit elements, resistor, inductor, and capacitor. Then, first element taking that is resistance. First of all, the resistance you can denote it by the symbol. This is a material, capacitive material. It can be denoted by like that. Then the resistance you can identify with a letter resistor R. The main property of the resistance is whenever a current is passing through the element, then the electrons some amount of energy will be lost. That amount of energy we can identify, that is the voltage drop across the resistance. Then, if voltage can be dropped across the resistance, then that voltage you can calculate according to Ohm's law. What is Ohm's law? At constant temperature, the voltage is proportional to the current. From that, the proportionally constant resistance R, then V equal to IR. When a current I is passing through resistance, then the voltage drop will be across the element R, V equal to I into R. This is the voltage equation of the resistance. From that, if we know the value of the voltage, then you can find out the current passing through the resistance. That is VI equal to V by R. Okay, these are the voltage and current relations in resistance R. If we know voltage value and current value, then simply we can find out the power loss across the element. That is, the power you can denote it by capital letter P. That is, P belongs to the power loss in the element. That is, P equal to V into I. The product of voltage and current is nothing but the power loss in the element. If we know voltage value, then the current can be replaced by V by R. Then the formula can be as that is V square by R. This is the power loss in terms of voltage. Similarly, if we know current value, that is V can be replaced with IR, then the formula can be changed as I square into R. Okay, they are the formulas for power loss in case of resistance R. V square by R and I square into R. Whenever we know the values of power, then energy can be, you can calculate it. That energy you can identify, that is integration of the power with respect to the time. That means that is integration from 0 to suppose time t. What is the value of power? That is, suppose p is constant, then taken as t outside. Then what is the integration of constant? That is with respect to dt, then the value becomes t. Then we know the values of power, that is v square by r. Then we know the values of power, that is v square by r into t. Or in case of current, I square r into t. These are the formulas of power loss and energy across the resistance R. V square by R into T, I square R into T. Okay. After knowing the resistance value, the second element you can take as, that is inductor. It is denoted by capital L. Whenever sufficient wire you can take, it can be twisted, then a number of turns are formed. That is called the inductor. It is denoted by capital L. It can be created the magnetic field whenever a current is passing through the coil. Okay? Whenever a current is passing through the coil, then a magnetic field is created. That means the flux will be generated. Then if the current changes, the flux also changes. According to the rate of change of the flux, a voltage can be induced in the coil. That means that induced voltage is proportional to the rate of change of the current. That is di by dt. Suppose the proportionally constant V equal to L into di by dt. This is the voltage equation across inductor coil. If you know the rate of change of the current, then the voltage we can calculate V equal to L into di by dt. Whenever we know the voltage value, then you can take cross multiplication, that is di equal to what happened, that is 1 by L V into dt. 1 by L V into dt. That means if we know the current value, we require the current value, then we can eliminate differentiation. How to eliminate differentiation? Simply we can take integration on both sides, then derivative term will be eliminated. That's why the current becomes I equal to 1 by L is constant, then integration of 0 to t V into dt. Okay, this is the, you can take integration with initial zero conditions. If you take initial conditions, then you can take plus V of 0. Okay, this is the current relation in case of inductor. After knowing the equations of voltage and current, then you can calculate simply the power in case of inductor. That is, you know the formula V into I, simply, that is, what is V formula? L into di by t. That is I into, that is L into I di by dt. That is simply taken as di by dt. Okay, that is the formula of power. If you know the formula of power, then simply what is the energy stored in case of inductor? Energy stored in inductor L. This is very important formula. That is energy stored in case of inductor. Then we know the formula for energy. What is the formula for energy? That is energy E equal to integration of 0 t power d into dt. Okay, na? If you know equation of power, that is L into I di by dt. That means 0 to t L di by dt, L into I, then dt. Then simply dt will be cancelled. Then the differential term dt will cancel. Then what happened? That is L is constant taken outside. Then integration of 0 to t I into di. Then you can take integration with respect to I. What is the integration of I with respect to, that is I square by 2? Then simply the formula in case of energy stored in case of inductor, that is E equal to of Li square. This is the energy store formula in case of inductor. Similarly, if we take third element, that is capacitor, the main property of the capacitor is to create electric field. The capacitor is denoted by the letter C, capital C. That means the symbol of the capacitance is nothing but Two electrodes are formed in case of parallel. Then this is the capacitor. Whenever it is create electric field, that means whenever a current is passing, then charge will be generated. That means the charge will be the rate of change of the charge, nothing but the capacitor. You can define the charge per unit voltage. That is called the capacitance. We know that is the charge we can define Q into Q equal to current into time. From that, suppose we can take the differential element that is dq, then take it as di. From that, what is current value? I equal to dq by dt. From that, you can take multiply and divide the differential voltage. Then what happened? We know I equal to dq by dv nothing but the capacitance C. Then dv by dt. Okay, this is the current relation in case of capacitor V, capacitor C. Then, if we know the value of current passing through the capacitance, then simply you can find out the voltage can be stored, can be developed across capacitor in nothing but from that you can take as dV, that is 1 by C I into dt. Okay, then you can eliminate like that derivative will be eliminated then by taking integration on both sides. Then integration on both sides. Then what happened? That is V equal to 1 by C integration I into dt. This is the voltage equation in case of capacitor. Then after knowing the value of voltage and current, then simply we can find out the power in case of inductor, that is P V into I, that is V into what is the I value, that is above the equation, what is the I value, C into dV by dt, that is C into that is dV by dt. Okay, na? Then that is the value of power. If you know the value of power, then simply we can find out what is the energy stored in case of capacitor. You know the formula, the energy stored in case of capacitor, nothing but that is you can take integration of 0 to t, that is power into dt. Already we know the value of power in case of capacitor. Then from that you can replace the value of power, that is 0 to t V into C into dV by dt again into dt. That dt will be cancelled. Then C is constant. Then you can take integration of V with respect to dV. Then what is formula here? That is for V integration V square by 2. Then the formula for energy stored in case of capacitor is of Cv square. The integration of V with respect to V, that is V square by 2. Then already C is there. That's why the formula becomes of Cv square. Okay, like that you can derive the voltage equation, current equation, power equation and energy equation in case of circuit elements, resistance, inductance and capacitance. Okay, then please subscribe our channel and share to your friends.